Hello, I'm Carrie Sundro with Alpenglow Industries, and today I have with me iShot JR, who is also representing Alpenglow Industries today. We have David of Cyber City Circuits and Jason Coon of Evil Mad Scientist. Am I getting
Evil
that
Genius
right?
Labs.
Evil Genius. Sorry,
Yes.
Evil Genius Labs. He is also a mad scientist, though, when it comes to LEDs. Let me tell you.
I aspire to one day be as cool as the people at Evil Mad Science Labs. They're
They
amazing.
are very cool. They are super cool. I have one of their giant 555 timers that I put together, and like that is definitely one of my favorite shop. I guess it's a functional art piece, although I haven't actually fired mine up.
I was gonna say I built it. I haven't ever actually used it in a circuit to see if it even works, but
maybe that will be a future live stream topic. Fire up your giant 555s. Well, cool. I feel like, let's see. I should probably be looking at this on YouTube too. I don't know if I have a viewer count available on StreamYard. Doesn't look like it, but maybe we'll just.
I got it up on YouTube also.
Oh, nice.
There are 3 people. I guess there's 3 people including.
Yeah, that might be 3 of us. Well, we'll hang out for a few minutes before like starting.
How many people came last time?
There were like 5 or 6 that kind of wandered in and out. I should probably tweet about it too because.
Are you recording this?
Yeah. Yep.
Good.
Live on Twitter. Hey, Sawara Links, how's it going? And JP, awesome. Hey, we got some peeps. Ooh, and hey, I just got a text from Robin, who's my employee at Alpenglow Industries, that she and her dad are watching. Super cool. Hello, Robin and Kevin. How's it going? Yeah. I figure we'll still just like kind of hang out for maybe a couple more minutes. Maybe I'll solder this row.
Yeah, you might as well get started. You got a lot to do.
What's that?
Yeah, I said you got a lot of them to do. You might as well.
I know. Better get cranking.
Get started.
Or else this stream is going to be like starting a soldering kit and never finishing it, right?
Didn't we already do one like that?
I was exactly.
Yeah. How is the Nixie clock coming? Did you finish it?
I cleaned it off of my bench today so that I would have room for this. And so no, I have not finished it because I was out of town this weekend. So did not do that. But yeah, I have all of the parts kind of very carefully like separated and ready for next time. Still thinking about how to solder in those sockets. I think, Jason, that your idea of using the tubes to like hold the sockets in place might be the best. Although I'm very interested to try out Liz Blitz City's DIY's suggestion of blue tack. So,
are you using a different tip this week, or is it just the angle doesn't make the little hook visible?
No, I'm using the same tip.
Oh,
same bent tipped Metcal.
Yeah.
So, yeah, it might just be.
I think it's like more top down today, and so it just looks straight.
Oh, interesting. Yeah, last time we might have been like a little bit closer to the camera last time because I was using the vise.
Yeah.
So today we might be like a little bit farther away, although zoomed into different levels too, I think.
So I have a question, Carrie. What are you doing right now?
Oh, right now I'm soldering these LEDs that are part of the latest and greatest Cyber City Circuits soldering kit. And this was designed by Jason, Evil Genius Labs here. And I missed a few. And so the cool thing about this kit is that when you're done, you have a wonderful Fibonacci spiral of LEDs that make super beautiful light patterns. And Jason has been designing these Fibonacci kits for quite some time, and he has all sorts of variations. which I will let him tell you all about. But he and David collaborated to bring to life this kit that actually allows, us to solder the LEDs in place, which is kind of cool because, as you can see, they are tiny little surface mount guys, and so they're not very hand solder friendly as they are. So each of them are on this little individual breakout board that you can solder headers to, and then solder the LEDs onto the actual board.
And you got
And
8 of them.
I'd like to add.
Sorry.
That's okay.
I try.
I like to add that we are currently out of stock on these on our store, but we do sell them at shop.cybercitycircuits.com. If anybody wants one, go ahead. They're available for air quotes pre-order or back order, and as soon as we can get the time to make some more, we'll make some more and ship them out. I hope to have some more done within the next couple of weeks.
Cool.
I have one available mint in box for $50 if anyone can't wait that long.
There you go.
So
I have one pre-assembled for 60.
Damn.
So you just get through 8.
They're $30 if you feel like waiting.
How many is there total that need doing, Carrie? You just did 8 pretty quickly there. What's our grand total that we got to get to?
32. And
okay.
I have, I think, 24 done already. So this is my last batch of 8 here. But I'm going to save them for a little later for our super speed soldering contest, which I'm not quite sure how speedy I will be, but we will find out. But if you have a kit and you're interested in doing the contest, or if you just have like a solderable breadboard with some 10th-inch headers, you can also do the contest because that's pretty much just what we're doing. But what we're going to do is we're going to break out, I think, 3 of these, and we'll put them in line on the breadboard with the headers. And then we will preload tweets on our phones. And then we'll say like 1, 2, 3, go. And solder, 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 solder. Quick grab the preloaded tweet, take a picture, and post it. And we'll use Twitter as the decider of who wins. So that will be it. And if you win, you get to pick one of our like little soldering kits. We got like Happy Rain Cloud, PS I Hate Yous, I Voted, or PCB rulers, either diodes or transistors. So no, we're not starting it, Alfred. Don't worry. We're not starting it. It was just getting everybody prepped. I figured I would have Jason talk a little bit first about how exactly did he get into all of these Fibonacci's? How did he get into the downward spiral of Fibonacci here?
Yeah. So should we show what the kit will look like assembled?
Yeah, I will.
Or do you want to save that for
give you front billing here?
So this is what the kit looks like when it's assembled. And yeah, it's 32 addressable RGB LEDs. And it's driven by a Arduino Nano that's mounted on the back. And then it has 2 little buttons on the side over here. And so one of them changes brightness, so we can make it brighter.
Nice.
I'll tone it down a little bit for the camera. There we go. And then the other button will switch between pre-built patterns. So there are, I don't know, like a dozen or 2 pre-built patterns. There we go.
Super cool.
Yeah. So yeah, I got started a couple of years ago, my descent into Fibonacci madness. So I'm a software developer, software engineer by day, but I did take electronic engineering or electronics class in high school, 4 years of electronics in high school from a great instructor named Marty Warren. Hey, Marty, if you're out there. And actually started to go to school for electronic engineering before switching to computer science. And then didn't really do much with electronics for quite a while. I won't say how long, until about 6 years ago, thanks to Arduino and the amazing tutorials and kits put out by Adafruit, got me interested in it again, and that kind of started the whole thing for me. I got started with RGB LED matrices with Louis Baudouin with Pixelmatics. And we had a Kickstarter called Smart Matrix, and then Louis still sells Smart Matrix kits and adapter boards. But then I was talking to Louis, and I got interested in non-conventional displays because a matrix is just kind of a expensive, low-resolution monitor. And don't get me wrong, I love LED matrices, but
they're so square.
They're very square, and I wanted to make a round one. So, and about that same time, I was watching a video by Vihart on YouTube about the Fibonacci sequence and the golden ratio and the golden angle and golden spirals and how plants naturally use the golden angle to arrange their leaves for maximum sunlight. And so I
in math class series, right?
Yes, exactly.
Okay.
Yep.
Yeah.
It's a great
fun
series.
Yeah, great animation.
Yeah, highly recommend it. But so I was talking to Louis, and I actually I wrote a script to place LEDs into a Fibonacci spiral or a Fermat spiral, and actually sent it to a PCB manufacturer or engineering firm that does routing. I didn't know anything about making PCBs at the time, and they responded that it was impossible to route, that they couldn't do it, and that sparked me to learn what I needed to know to do it myself. And so the very first one that I did was the Fibonacci 64, which is 64 LEDs in 86 millimeters. So the engineering house, I just placed the LEDs, on the board in the software. I didn't route them, didn't give any order. And in fact, the order was probably very literal, starting from the center, working out by radius. And so, to route those, the route would jump from, one side of the board all the way to the other side, and, back and forth, because every time you increase the angle, you increase the radius a little bit, you also rotate by the golden angle. And that is very hard to route by, but I realized you can just take any number from the Fibonacci sequence, which is, add one number to the previous number from the sequence. So, 1, 1, 2, 3, 5, 8, 13, etc. Take any number from the Fibonacci sequence and go that number of LEDs out and follow that all the way to the edge, and it will make a spiral. And so that's how these boards are routed, from the center via Fibonacci spiral out to the edge of the board, out to the next one, and back into the center.
I'm really surprised they told you that.
Sorry, I didn't catch that. David, did you hear that?
No, you're a bit.
That was Carrie. Carrie, your mic is muted.
Yeah. It's not muted. It's just not. It's working strangely.
Well, her workbench mic is working, but her face mic isn't working.
Yeah, it is. It should be workbench
mic. It's good. It was just behaving strangely for a moment there. Try again.
Oh,
yeah. Sorry.
Oh, I was just curious. I was curious about them saying that it was an impossible board to route.
And I don't know that they said impossible. Maybe they were just saying they didn't want to do it, or
it is not rectilinear. We don't want any part of it.
I guess it may have also been because, again, I knew nothing about PCB design at the time. Not that I know much more than that now, but I probably had them ordered in logical Fibonacci order. So it would the route would have needed to gone from this side of the board all the way across to the other side of the board. And I don't doubt that is impossible to route in that way. So they may have taken my ordering of the LEDs too literal or as a requirement. So,
Hmm.
but yeah, so I did the 64 first, and then I went up in quantity but kept the board the same size. And actually, the first 64 that I did, I used using 5mm square LEDs. So then I wanted to see, sorry, that one. 64 of the 5mm square LEDs, and then I wanted to see if I dropped down to the 3.5mm LEDs if I could get twice as many LEDs in the same amount of space. So this is the 128 in the same size board, just using smaller LEDs. And then I jumped to the 256. Decided to stick with powers of 2 for the LED count. So the 256 in a 166mm PCB.
How did you decide on the diameters of the PCB?
Pretty randomly. I mean, I had a general size in mind, and actually wrote a script in processing that would that I could try different diameters, different LED counts, different sizes of LEDs, and you know, even margin, you know, for like mounting holes on the side. So yeah, there's. Go ahead.
I was just say when you get an order, you just bust out the soldering iron and start soldering 256 LEDs down, or how does that work?
No, and I realized I should back up. Another thing that heavily inspired my descent into the Fibonacci madness was Jim Bumgardner. So at the time, it was on the Fast LED community, which was on Google Plus at the time. He made one that was kind of like this, where it was a bunch of holes drilled in a flat, I think he used particle board. And I did for my first build as well. This one's metal. It's just a bunch of holes drilled. So, you know, he made a template, drilled holes and mounted, I think it was 100, the one that he made, 100 LEDs, and then used these 8mm addressable, I think they're WS2811s. So he definitely, you know, shout out to Jim Bumgardner, definitely inspired this journey for me. But so I actually made some of these by hand before I even made the Fibonacci 64 PCB, just by hand. But they're very labor intensive. I also made this one, which is 200 of the same 8mm LEDs mounted in it's a stainless steel mixing bowl. Because again, I like the non-traditional, non-square form factors. I also like breaking out of the two dimensions whenever possible. So this is 200 holes drilled. In this, I bought a drill press because I got tired of doing this with the hand drill. And then I just bought these pre-strung LEDs and arranged them, and I just kind of ran them however it made sense to do it physically, and then just mapped them logically in software to the Fibonacci order, and also mapped it in, you know, X, Y, X, Y, Z axis, and then also polar coordinates, so angle and radius.
The inside of that thing is gorgeous.
Oh, thanks. Yeah.
Kind of like jellyfish or something you'd find deep in the water or something.
Yeah. Here, I'll plug it in.
Oh, we haven't seen it plugged in before, I don't think.
Ooh.
So I have the brightness turned way down, but
I was gonna say when I was listening to that previous one, it's like there's no diffusion and it's got like a metallic thing behind it. I was thinking it was gonna be blinding.
Yeah, definitely with the brightness turned up, and you get a really cool effect because this is like brushed stainless steel, so you get almost like a with the brightness turned up, you get kind of a infinity mirror effect almost down the sides of it, but it's a little hard to see on camera. So yeah, anyway, I was making these by hand, and it just doesn't scale very well. It takes a very long time. It's very labor intensive, especially the ones that are holes drilled into metal. So that's when I went down the PCB route, decided to give that a shot. So with a lot of help from, again, Louis Baudouin with Pixelmatics, he really helped me get started. The huge shout out to SparkFun, has a great tutorial series on Eagle, which is what I learned with, for better or worse. And you know, keep meaning to pick up KiCad, but just haven't gotten around to it. But so yeah, I followed SparkFun's tutorials on Eagle, and that's how I made the first Fibonacci PCB, and just had them. I had some manufactured by JLC PCB, but at least at the time they were having yield problems with their LEDs. I don't think they were following like the moisture precautions, and I was getting maybe 50-50 or lower yield at the time. I think they've improved their processes since then. But then I also worked with Ben Hinke with Pixel Blaze, LED Mage that makes the Pixel Blaze. And he manufactured some 64 and 128 and 256 boards for me. And then I think he got really busy with his Pixel Blaze V2 or V3 crowd supply campaign. And then, met David with Cyber City Circuits, and he has been assembling 256s. So any of the 256 boards that you get now were most likely assembled by David at Cyber City Circuits. The smaller boards, the first few that I got, I actually, bought stencil, bought the PCBs from Osh Park. I got a stencil made from Osh Stencil, and learned how to use solder paste and made my own reflow oven. I followed Adafruit's tutorial to make the easy make reflow oven out of just a $30 off-the-shelf Black & Decker toaster oven.
Nice. So there's some very limited edition, early vintage purple ones out there.
Yeah, there are. And
collectible now.
Yeah, and then so once I went to the 56, I decided to go the other direction and made 64 mini. So smaller PCB, smaller LEDs, and then I did the 32 mini. And yeah, you can see this is Osh Park After Dark finish with the clear solder mask. And then I did another version of that with, because the After Dark finish isn't that impressive when you have just copper fills. Copper fills everywhere. So I made one with a hatched fill on the back, which is a little bit more impressive, but I've still seen other PCBs in the After Dark finish that look much better than that. And then the 64 micro, which this is in Osh Park purple. Kind of hard to tell on camera, but I swear it is. So yeah, I still, when I make a new prototype, I almost always buy my first set of boards from Osh Park and get a stencil and hand assemble at least the first couple of revisions of the PCB before I get it nailed down and send to the experts to handle manufacturing at higher volumes like Cyber City Circuits.
Jason, real quick, the obligatory, which are those over your shoulder question?
Yeah, so after going up to the 256 and then back down to the 32, I decided to go, so one of those is a 256 just mounted in a nice wall hung enclosure. And then one of those is a 512 in the same space as the 256. There's twice as many LEDs in that same space. This one is a 512 in a 320 millimeter PCB, which I will grab one here. That's what that monster looks like. Whoa. Compared to the 64. And then this one is actually an experiment. It's a set of concentric rings that I did not make or design, but it's 1,600 some LEDs, 20 sets of concentric rings, and it's about 15 inches in diameter. So,
are there any constraints that stop you from taking it further, like power usage or cost or other physics reasons?
Yeah, definitely. So already the 320, the 256 is about the biggest that I can do in my own reflow oven, and I don't have the patience to paste and place 256 LEDs on the PCB. So that's my personal limit for manufacturing right now. I have talked to the fine folks at Cyber City Circuits, and they tell me they can handle a 320 millimeter PCB. So very excited about a collaboration with them in the near future. I have some prototypes and some beta test units, but that's about it. Aside from that, it just depends on the PCB manufacturer. Like I'm not sure offhand what Oshpark's size limit is on their panels. I think JLC is 400 by 500 roughly millimeters that they can do on their panels.
Any memory limits on the microcontroller with the larger numbers and calculations?
Yeah, so all of the kits that I do, I'm still using the ESP8266, and it runs a web server, and it runs fast LED to drive the LEDs. And up to the 256, they're all driven with a single data line. But yeah, it takes 30 microseconds to write out the LED, the data for one LED. So if you have thousands of LEDs in one strand, you'll very quickly start hitting frame rate limits. And then depending on the LED, they can take anywhere from 30 to 60 milliamps for each LED at full brightness, solid white, with all three inside. There's a red, a green, and a blue LED. With all three of those on full blast, that makes white. And those max out at somewhere between 30 and 60 milliamps. So you definitely start running into power issues. For the 512, I split it up into 4 separate data lines. And then I use fast LEDs, 4-way parallel output on the ESP8266. So instead of writing out one LED's worth of data in 30 microseconds, I think it is, it can write out 4 LEDs worth of data, one to each line. So you can run up to 4 times as many LEDs at the same frame rate. So I did put pads on this if you do feel like, or if you don't care about the frame rate limit. There are jumper pads out here on the edge that you can solder jumper. You can bridge those to run it in, any combination up to, between 1 and 4 data lines. And yeah, as far as power concerns, I always make the back and the front large copper pores or fills to try to handle, just in case somebody does turn it on full blast. You'll need a large power supply. Your power supply would give out before the LEDs of the PCB do.
Nice.
Yep.
All right. So I'm trying interesting ways maybe of assembling this. So I read the instructions, sort of, because I was like, oh, I think that there was something about that nano and the order of operations, and like, yeah, sure enough, it would be a real pain in the butt to solder it. Well, you can't really solder it after the LEDs are soldered, so you have to solder the pins for the nano in first.
Put the pins on first, and if you want to, you can use the removable, the header pin sockets if you want to be able to remove the nano later.
Yeah, but you can't use the cool
right?
Kit, right? So,
yeah, so
yes, and I want the cool diffusion.
Yeah, so I made a acrylic kit, black LED acrylic from Tap Plastics. Yeah, it won't fit in there. It will, not with the standoffs. I include 10 millimeter standoffs for the back between the PCB and the back acrylic. You would need to go to maybe 12 or 14 millimeter standoffs to make the nano removable. But those nano clones are like $3. So, and if you ever want to drive this board with something other than the nano, there are data in headers. So putting the nano on there now won't prevent you from driving it with something else in the future.
Nice.
But yes, you do need to put the nano pins and assemble those into the PCB first, and then don't assemble the nano onto those pins yet until after you do the LEDs.
Pins, then LEDs, then nano.
Yes. Yep.
You got it. And
so yeah, the
board to hold it in place, because fortunately the nano footprint is breadboard compatible.
Yes.
So yeah, that's what I'm doing, because that gives me like a nice flat surface, and so it'll probably be square, hopefully.
Yeah, I think I just used the nano to hold the pins straight while soldering them, but yeah, however works.
Look at that.
I saw the breadboard and I was like, how's that going to work? I didn't realize you're doing the nano, and I was like, there's no way those things line up like that. That's not going to work. What's going on?
Well, and at first I put the long the long holes in, like through
Yeah.
the board, and then but my breadboard doesn't have like there isn't enough pin on the short side for the breadboard to hold it. So then I decided, well, you know, I can just put the short side of the pins through the board here, and then I won't have to clip them on that side. Win-win.
I didn't want to sidetrack the conversation earlier, but people are asking about the soldering challenge, what it entails, what's required, what preparation.
Yes.
Touch on that?
Okay, so if you have the kit, you need 3 of your little LEDs, and this is just sort of prep work. We're not going to start it quite yet, but 3 LEDs. Well, maybe start
Carrie,
do it in like.
It might be good to spotlight the workbench video.
Oh, yeah. Let me do that. Let me do that. If I can. Hello. My computer is being very slow for some reason. There we go. Okay. So we have 3 of the LEDs here. And so what you can do is break them out. And I always like to use pliers and do this very gently. And that's because if you have capacitors on your board, they can actually crack due to the shock of separating boards, especially if they're close to that separation point. And also if you have traces that run really, really close to the edge of the board, sometimes the layers at the edge can delaminate and can affect those traces. So I'm always very gentle when I break out boards, and I try to kind of, you know, just gently wiggle back and forth like that. And then, so we'll take 3 of those and take some headers, separate them out 2 by 2. And if you don't have one of these kits, if you do have a solderless breadboard, some headers, and just some of the solderable, like one of the solderable breadboards, you can still follow along and do some kits. It's just soldering 10th-inch headers, basically. So we will clip off, let's see, there were 4 per 3, so that's 12. Or sorry, no, there are 2 pairs of 2 per board, so we'll do 6. 1, 2, 3, 4, 5, 6 pairs of 2. And then put them in the solderless breadboard. So that the 2 pairs of 2 are right on either side of the middle channel. And then we'll take these guys, little LEDs, and now if you have, you know, if you just have some solderable, you know, perf board or whatever, you know, just put it over top of your headers, however you want, so that you're like that. So yeah, go ahead and prep that. And also we'll prep that, and we'll come back and we'll tell you the second part of it, which is how to prep your tweet, and then we'll actually do it. So I'll give everybody about 10 minutes to kind of get up to this point.
Just curious, Carrie, your spacing there, is that for ease of removal, or?
Yeah, I mean, you know, the spacing is more or less arbitrary, and you know, since it is a speed contest, I could have put them closer together. But
that's what I was thinking.
You know,
that's what I would have done.
All right.
This,
could do that.
Are there any spacing requirements for the contest, or?
No. Well, you know, regulation solder is lead-free, 0.6 millimeter, like rosin core.
Definitely lead-free. So there was a good question in the comments about whether these LEDs will be available outside of the kit. And we'll talk about how we got to the kit and these LEDs specifically. But yeah, these LEDs can be used in a breadboard, as you can see on Carrie's breadboard there. And yeah, Cyber City Circuits is planning on selling them, and they're saying a pack of 10 of the LEDs for $5 with the LEDs already surface mount assembled onto the PCB. So
Nice.
which I think is less expensive than some other similar breadboard friendly LEDs that are available from.
It's the cheapest ones on the market.
Of course.
Shot fired.
So, Carrie, I'm sure that you read the instructions and are following them, but for anybody that's following along, you'll definitely want to read the instructions and make sure that you are getting all the markings on the PCBs lined up, because they are polarized.
Yes.
And yeah, the easiest way to tell is with the little black dot. Those should all point out towards the edge of the board.
Oh, check that out. Cool. I was lining them up by the letters on the board. So there's V, I, G, and D. It looks like. Can't tell if that's a D.
Oh.
Oh.
So
okay.
I and O for in and out.
In and out. Got it.
V and G for 5-volt and ground.
Ground. So the I and the V are the easiest for me to tell apart and to match up. And so I'm lining up the I and the V on the little board with the I and the V on the main solder kit there.
Yep.
Here, you got some tin silver copper here. Is that going to be legal or?
Oh,
We'll allow
it. Yes. No, you can use any type of solder, any iron. It doesn't really matter. I'm trying to use all lead free these days because it's just, better
Likewise.
for the environment.
Is that the Heiko Ultivice? What is that called?
Omnivice. Yes.
The Omnivice. Tell us how much you love the Heiko Omnivice.
So this is kind of, I've only used it a few times. I used it for the last stream and I'm using it for this stream. And I have to say it was weird and I didn't quite know if I would like it to begin with. But I do kind of like it. It's a little weird for me for like boards to be this cantilevered, but boards are small, and this thing is very heavy. And it's pretty easy to just like screw and unscrew. The only thing is that I wish that, I wish that somehow the top, like that this guy was maybe attached to the top or something. And I understand why they kind of do that. It's nice for this top part of the vise not to rotate. But it also means that you constantly have to like pick it up and like put it in again. So I don't know. I wish that there was something there that would kind of like hold it up like that. But that's okay. It's a very minor gripe. It's pretty handy, I have to say. I should probably buy 2 of them so I could like put one on the other side of larger boards. They are kind of expensive though. They are kind of expensive. That was the other thing. They're like $60, I think. So I was kind of like, ooh, $60 for a vise. I could just get like one of the Panavice things, and I think they're a little cheaper. And
I was going to say, if you want one but don't want to pay $60, I think it was Colin Hickey shared this 3D printable version.
Ooh.
And the top is knurled threaded. And you can make it in different heights if you wanted to. And I just filled mine up with BBs for weight.
Nice.
Yeah.
Nice.
And it works pretty well.
Cool. And you can just print another one if you accidentally melt it. No big deal.
Exactly. I printed this one in PLA, so I wouldn't want to get my board too warm, but you could always use PETG or nylon or, whatever, ABS.
Nice. Nice. All right. So Jason, tell us about how, like the challenges in making all of these, you have all these beautiful designs that are all surface mount LEDs, and now you're trying to make it like solderable and make a kit out of it. What kind of challenges did you have in converting your surface mount design into an LED solderable one?
Yeah, so David at Cyber City Circuits approached me about collaborating on a kit because they have the great monthly the Cyberbox, the monthly soldering kit. But they have some constraints, right? No surface mount soldering. It all has to be through hole. And then even beyond that, my first thought was, of course, a Fibonacci soldering kit, but everything I've done is all surface mount, and there are through-hole solderable addressable RGB LEDs available. You can buy some from Adafruit, for example, but the leads on them are very fine pitched. I think they're like 1.27 millimeter pitch, and can be challenging even for, go ahead.
Oh, sorry, 0.8 millimeter pitch.
Oh, yeah, so even worse. And so, yeah, they're, challenging even for, more experienced solderers. So, so that was out of the question. And so then, yeah, we were looking at, breadboard friendly LEDs, but they're rather pricey, and bulky, and six pin as opposed to 4-pin. And so, yeah, we both decided that this would be a good idea to try this. I'm not sure David was expecting them to be quite so small. Of course, I made them as small as I could, just wide enough to span the gap in the center of a breadboard, and as narrow as they could be. And I got, we managed to get it down to just 2 breadboard spacing, wide. So, what is that? They're, is it 2.54 millimeter spacing, I think?
Yeah. Yes.
Right.
In fact, you can perfectly fit a header before you break them apart. You can perfectly fit a header down like a row of them. And I did something really stupid before the stream a little bit earlier, where I did just that. I was like, oh, I'm going to save so much time. And so I put like a header strip and a header strip in the breadboard, and then a whole strip of the LEDs. And then I soldered them all together. And then I realized that my headers weren't broken apart.
It's very hard to separate the panels once you have the pins in there.
Very carefully go in between them and snip.
Yep.
Thankfully, like, these are my favorite cutters ever. $5, love them. They're very nice, very thin. They fit in between.
Don't feel too bad, Carrie, because I did the exact same thing, and Alfred just said he was going to do the exact same thing before your warning here. So I think it would work if you broke up the header pins before you did it, then it would work. And then the only tricky thing is you have to make sure you get it really clean cuts, and you might even have to clean up the edges to get them to sit side by side. Yeah,
that's the thing. Once you cut them, they tend to be like a little bit over that perfect 2.54 millimeter pitch when you put them in a breadboard. So
one of the problems that you're going to have if you do that, if you do the breakaway first, but you leave the panel panelized, is that when you go to break the panel away, you can only break them away with the LEDs hitting each other. Like, you can't go the other direction anymore.
Right. You can't flex them down and up. Yeah.
And that is sometimes a problem.
Yeah. And that's why the instructions clearly state to break apart your headers first.
Directions.
And the LEDs panels.
Directions. Yeah. We should all read them always.
Yes, exactly. And yeah, Alfred, I think I have the same cutters. Are these the Heiko cutters? Yeah. Same ones.
Yeah, I have 5 pair at the office.
Yeah.
Going back to these breadboard compatible boards, when I finally got them in my hand, they're amazing. Like, they are absolutely perfect. He couldn't make them any smaller, and if they were any bigger, they wouldn't fit very well on a breadboard. They're like 100% perfect for a breadboard.
Yeah. And so again, of course, the first revision that I did through Oshpark. So you can see they're in Oshpark Purple, and I used their automatic panelization, where you just get the spacing between the boards right, and they automatically add mouse bites. And then I ordered a stencil from Osh Stencil and just did this whole panel all at once. And then I bought these fancy Heiko depanelizing clippers, if you can see those. And those just fit right in the gap. They're just perfect to go in the gap. And I won't break it because I'm going to keep this beautiful Oshpark Purple panel intact, but you put it like that and then squeeze, and it depanelizes.
Too big again.
Oh yeah. So if you can see there, you get it up in the gap there, and it cleanly breaks away the mouse bite. So anyway.
Nice. How much were those?
I don't think they were bad. About like the Heiko side cutters, flush cutters.
Nice. So like maybe $10 to $15 range or something like that. Like
They might have been a little north of that. These are the DP24 ins, I think is what that says. Yeah, I'll see if I can drop a link later.
Cool.
If that's readable, legible, probably not. But yeah, anyway. So yeah, we got the panels working, and then I realized they're really hard to test, right? Like you've got, and we did panels of 128 of them, so 16 by 16, I think. No, anyway, I didn't route power and data and ground through the panel so that you could just test, one set of test points and test all 128 LEDs. So we're thinking the next revision of the panel will actually be routed with power, ground, and data to make them easier to test. But then they're V-scored. So I've never tried that. I hear it's possible to pass a signal through a V-score with vias. But I've never tried it, and we'll have to see if our PCB manufacturer is okay with that. So.
Speaking of testing,
David, I was just going to say, how did you test all of these?
I'm glad you asked. So, so we hired a developer recently named Tim, and that guy is amazing. So I said, Tim, hey, I have these panels of 128 of these LEDs. Figure out a way to test it and test them. And he did. And so he took 2 or 3 of the light boards without any LEDs on them, stacked them together, put pogo pins in them, and then he just went through and he was pogo pinning them all to see if they light up. And then he also took another light to go past it to make sure that each LED also passed data to the next light, because these things are all serial. So that's how the addressable part works. So we had to make sure that each one not only lit up on its own, but it would light up the one past it too.
Nice.
And it took him a very long time to test all of them. There was a lot of them. We ended up shipping 120 kits.
What was the failure rate like?
Not very many. So I think that every LED that he had that was bad, he would mark it with a Sharpie, and then he would just take that entire panel and set it aside. And I want to say there was only like 3 or 4 panels that were set aside. So we do have some extra of these breadboardable LEDs that we are going to put on site, because we're just going to break them up, put them in a baggie, and then we'll just take the ones that are bad and put them in the trash.
Nice.
Yeah, so when I was testing them, I bought this pogo pin adapter, and I actually I couldn't find the actual jig, but I pulled the middle 2 pins out, and it's just the perfect size to test one LED at a time. But yeah, like David said, that doesn't test that. That only tests that it's consuming the input signal, not that it's passing the data output signal.
Yep. Yeah,
and it's time consuming. Like at best, you're testing 1 every second or 2, right? Even at speed. So we'll definitely, to scale this up any amount, we'll definitely have to do a panel that can be more easily tested.
Yep.
Just wanted to report in that JP got all of his LEDs attached. I know that's not part of the race, but
yeah, nice. 40 minutes. Not too bad. Not too bad.
I'm not sure if that means he has the kit assembled or just the LEDs assembled.
He said the LEDs attached took 40 minutes, 1 hour to attach the headers. So
I think that means he's done.
Yeah, sounds like they're fully on there. Cool. Yeah. Okay, well, I think it's about time to do this contest. And this was sort of something, I'm going to blame Alfred. He kind of instigated this. He made a comment about like a soldering contest. And I was just like, yes, we can do that.
Hey, Carrie, before you get started, you might want to spotlight your workbench.
Oh, let's do that. Thank you. All right. So we got workbench here. Now, the last part of this is that we want to tweet about it. Oh, that's a glare. There we go. So we're going to preload a tweet in here because that's going to be the finish line is when your tweet hits Twitter. So I've preloaded it just with the word done. Definitely tag us at Alpenglow Industry at Alpenglow Ind so that we can like see it and don't have to be searching through Twitter for it. And then I just did the hashtag speed soldering. So it just says done at Alpenglow Ind hashtag speed soldering. And so what we'll do, we're not doing it yet, but we'll say like 1, 2, 3, go. You'll solder, 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 solder. And then when you're done, quick take a picture and then post the tweet. And then that will tell us who won.
And Carrie, what do they win if they do win? Is there a prize?
They win their choice of an Alpenglow Industries solder kit. We have Happy Rain Clouds. We have PS I Hate You. We still have I Voted ones, which you could just put another sticker on over to say like, I don't know, I vaccinated or something. And then we also have our PCB rulers. If you would like an awesome reference of pretty much every either diode or transistor pattern out there. Oh, look at that. I shot JR. He's holding them up. Here, I'm going to spotlight you for a second there. Choo. Yeah. So there are 2 of them. Green is diodes. It's called For the Love of Sod. And blue is transistors, and it's called What the Sot. And the cool thing about that is, for anybody who does their own PCB layouts, is that not only does it have like a nice reference of all the patterns, but it has all of the 50,000 different names that each pattern is called on it. So if you're wondering what the heck an SC70 is, that ruler will tell you.
So
right.
I highly recommend the PS I Hate You soldering kit. It was a fun challenge to assemble. So.
Woohoo! Thank you. And that is a surface mount kit. So if anybody is interested in trying their hand at surface mount, that can be one for you. Okay, so.
I just wanted to say, did we say to take a photo as well? Did we say that out loud?
Yes.
Okay. I just wanted to be sure. I couldn't remember if we made sure that was clear.
Yeah. Cool. So one more time, preload your tweet. Done at Alpenglow Industry at Alpenglow Ind, hashtag speed soldering, and then we'll solder, quick snap a picture, press boom tweet on that tweet, and then Twitter will tell us who won. Thank you, Swara Links. I'm glad you like the PCB rulers. Okay, so ready your engines. I'm going to put my phone over here so it's not in the way. I'm going to line up my board in what I think might be the ergonomically best thing. I do not have my hands on the soldering iron, hands on the table in front. Okay, cool. Alfred's ready. Excellent. All right. Oh, wait, hang on. I need to get my solder a little bit spooled out here in easy reach. Okay.
Are you allowing gambling? Can we bet on who's going to win?
Not officially, because I think the state of California might frown upon that. But hey,
depends on your local jurisdiction.
You can definitely place $0 bets.
You can say who you think.
I think Alfred is going to beat me for sure, but we'll see. Okay, ready, set, go.
I have 5 on you, Carrie. I know you're not eligible to win.
I'll heat back up. Thank you. Oh, I'm way too slow here.
It's hard to give a running commentary since I can't see the other.
I know, and I'm also trying to make sure that they're straight and that I don't accidentally, do them cattywampus.
Are we taking off? Are we disqualifying people for if there's because they're taking a picture if there's a a cold joint on there, do we disqualify?
Hey, if we see and if there are any visible flaws that indicate it will likely not work, or if like something is not soldered, oh, I'm done. Oh gosh, got to take a picture. Come on, wake up, phone. Where's the picture thingy? Camera. Go.
Yeah, and you're disqualified for melting the LED. For
Oh,
sure.
Oh man, I think Alfred totally beat me. His tweet just came in. Ah! No! Dang.
Nice work, Alfred.
Excellent. Excellent. Very good. Oh, let's check out his solder joints. Oh, they look pretty good. They do look like solder joints. Awesome. All right, Alfred. Tell me which of those wonderful prizes you would like, and I will ship one your way.
Carrie, you must be disappointed. I know you were excited about one of those I voted buttons, but maybe next time.
All right. But you know what? I am excited about putting my last 3 in here. And then I'm going to see how flipping it over is going to be.
Incidentally, JP powered his on and everything worked. And
yeah. Nice. Nice. Congratulations. All right, so I have all of mine on here, and I'm double
But they're
checking.
not soldered yet,
They're not soldered yet.
so you have to flip the whole thing over.
Yep, but I'm just double checking first. I'm doing your good cheater trick and making sure that all the black dots are towards the outside.
Do you have a piece of cardstock handy?
In fact, I
thought we were going to see a Newtonian demonstration of gravity.
What was the black dots? What was the black dots thing?
So
They all point out.
Yeah, you can see that there are black dots on each of the LEDs, and they are slightly to one side of the LED. Yeah.
And that's actually the little IC controller chip inside. If you zoom in on one, you'll see bond wires going from that to the 3 different LEDs inside.
Oh, next time I should have a third camera in arrears, and that should be the inspection scope, because that would be cool to get a close-up of.
That would be cool.
I have tweeted some microscope close-up pictures of those. So.
Nice. All right, so I'm taking a piece of cardboard, and I'm placing it over top. Ooh, this is going to be tricky. All right. Now is when you should be betting.
There it comes.
I have faith in you.
Thank you. Huh. Yeah. Excellent. I guess
So
I just
for everybody else playing at home, I have another suggestion. When doing through-hole parts,
What's that?
And when I do classes and I teach, I usually try to teach with masking tape.
Oh.
You just put all your resistors on there, you put the masking tape, hold it down, and flip it over. You put all your capacitors on, masking tape, you flip it over.
Mm-hmm.
So masking tape comes in real handy when it comes to these kind of things.
Yeah, I actually have little strips of masking tape on my bench that I just reuse for that exact purpose.
Hey, that blue stuff is expensive.
A long, fine soldering tip is handy for this part too, soldering around all of the other pins that you've already soldered. I think I also trimmed leads as I went to try to free up, especially if they were in the way. But of course, you can't do that with the nano pins. So
I can't. So how? I mean, these are just regular headers, right? Do you need to trim them?
I mean, you don't.
It looks like maybe
You have to do the ones under the nano. The other ones you could leave, but I don't know. What are we, barbarians? We're just going to leave.
I think I trim components. I don't necessarily trim big, thick headers.
I might be a little obsessive about mine because I trim them before I solder them, or I trim them and then I solder them, trim them, and then go back over them with the soldering iron so that they're nice and round and smooth. But I might be a little obsessive about it.
Hey, Carrie, tell us more about your process as you're soldering. When you apply the heat, you apply the solder. How do you make sure that you have a clean fillet on your pins?
Oh, so first of all, I just kind of started at the middle. I figured, it's Fibonacci. We should start at the middle. And then I just decided to do all of them that are in the nano outline first, just because that was an easy way of, differentiating them. So I am using a magnifier here. I don't know. There we go. You can see that. And because I, am, so I think I said last week I was 43. I forgot I had a birthday recently. I'm 44. And, my eyes are not what they used to be. And so I'm using a magnifier, which is helpful. And basically, I turn the board every which way so that I can get access to the pins more easily. And what I do is I basically touch the pad, the iron to both the pad and the pin and the solder at more or less the same time. This solder is lead-free solder, so it takes like a little extra effort to flow. But it has flux in it. I haven't pre-fluxed anything on this board, just because that would require like a bunch of cleaning. Well, wouldn't necessarily require it, but you might want to do a bunch of cleaning. So, yeah, I am just adding solder as I go. And, a lot of times, especially for through-hole parts, you might flow like halfway around the pad and not the other half, and that's no big deal. You can put iron to the pad and drag it around and reflow it. So as I'm going around, I'm also looking a little bit at the pins that I've already soldered, just to make sure that they look good from other angles.
But the key is to heat the joint, not just to melt the solder. You don't melt the solder and pull it around the joint, right?
You have to touch the pad and the leg with the tip of the iron. And that's kind of why I like these weird bent tips. I don't know if you can see that. See if I can get the angle in there. But the bent tips kind of allow you to get more iron surface on the pad. So I find that they flow a little bit easier especially than just a really pointy straight tip. You might think that for, fine work, you want like a super pointy tip, and that would be helpful, but it's really not. They're hard to work with. Slightly blunt tips are better, in my opinion, because they will actually conduct heat a little bit better. Because the tip of the iron is actually the coolest spot on it, the very, very tip. And I also see people when they first are learning how to solder, what they'll do is they'll try to like use just the tip on the pad, and that really, like, I don't know if you can see, but it's not really heating the pad or the leg or the solder. It's like really hard because the tip is actually the coolest spot. So you want to use the side of the iron, like a little bit just aft of the tip, and then when you do that, your solder will melt and flow all the way to the pad. And the flux helps with that. It makes the solder, I think it changes like the, not the viscosity, but like the wetting properties of the solder. So it makes it flow a little better to pads and up the legs. And it also makes sure that the joints are super clean and free of oxidation, which can inhibit heat transfer and make your solder not flow as well.
Yeah, I actually use a surprisingly large, fat wedge tip on my soldering iron for just about everything, even fairly fine pitched surface mount soldering, just because it conducts heat so much quicker. Yep. You can get, into and out of the solder joint that much quicker.
Yep. Yeah.
Like if the tip, like use the largest tip that doesn't, obstruct you from getting into where you need to get.
Yeah, exactly. I'll use chisel tips a lot too. I might use one of those for like the next stream. Just to.
What'd you use for PS? I hate you, Jason.
Same fat wedge tip that I use on just about everything. Yeah.
I haven't tried it yet, and I'm a little nervous. I bought a bunch of really fine tips, and I'm really not liking any of them. And just my big old chisel is great.
Yeah, so you won't be able to see it because it's not heated. And before turning off my soldering iron, I always coat the tip in solder.
Yep.
Just to prevent it from oxidizing. So you won't be able to see it very well, but you can see the tip that I have on mine is fairly fat. Yeah, never mind. This is another one that I have, but it's also coated in solder, which is also not a bad idea. When you're done with your soldering iron, before you turn it off, clean the tip, coat it in solder, and then turn it off and let it cool, and let the solder blob form on the end and protect it.
It's a little hard to see, but those are maybe like 2 and 3 mil or something.
Yeah, I honestly don't know what size they are, but I'll see if I can find a link.
But the key and the most important part is the surface area of the iron on what you're trying to use it on.
Right.
So
the
if you have
needle
a small
point tip.
conical tip, you don't have a lot of surface area.
Yep.
Uh-oh.
Did you see your battery warning, Carrie?
Carrie, I don't know if you could see this, but discharge your battery.
I can put it back plugged in wherever it went. Ooh.
Extreme close-up.
Yeah. Sorry.
And what kind of iron do you have, Jason?
Mine is a fairly cheap. I think I don't even know how to spell. It's a lot of vowels. AOU. I'll see if I can find it. AOYUE. But it's a fairly cheap, temperature controlled. It was my upgrade from a non-temperature controlled Weller. One of the $15 Radio Shack specials. Which, yeah, if you've tried soldering before and have found it frustrating, I would start by getting a good. And it doesn't mean expensive. I definitely don't have to pay more than $100 for a good, even just like a Heiko temperature controlled soldering iron.
Yeah, Adafruit actually sells some very decent soldering irons that they don't really have a stand or a base unit or anything. They just plug directly into the wall. And they are meant for lead-free soldering. They go to those higher temperatures and they are temperature controlled. And they're like $30. And they are compatible with Hakko tips, which are not too expensive. Hakko or Heiko? I'm not actually sure.
However.
Hakko, I have no idea, honestly.
Another thing I'd like to add is if the number one thing I see that people have problems when they're soldering, because we send hundreds of kids. If your tip doesn't hold solder on it, like if you try to melt solder and it just rolls right off, you need a new tip.
Yeah.
So your tip should always be shiny. It shouldn't be dull. If it is dull, try to add a little bit of solder to it, clean it, use a wet sponge. Cellulose sponge is the preferred kind of sponge, or a brass scrape sponge.
Yeah, I like the brass ones best.
Yeah, I definitely prefer the brass.
But specifically brass.
Yeah.
Don't use steel wool. So the reason you would use brass is because the tip will break the brass before the brass breaks your tip. Steel wool will break your tip. So that's why we use brass for that. But yes, your tip should always be clean. If you don't have a nice, shiny, clean tip, you will have a very, very, very difficult time soldering.
Yeah.
I was going through tips pretty regularly when using like a wet sponge. And I found since I switched to brass, I have yet to, burn through this tip. I'm on the same tip that I've been using probably 2 years now.
When you say going through, what was the failure that you're experiencing?
Like when I was soldering a lot regularly, maybe every other month or so.
Sorry, I mean like were they oxidizing? Were they?
Oh yeah, sorry. Yeah, like David said, I was not able to clean it. Or if I could clean it and get it shiny, it wouldn't hold solder on it. So if it's black, and then like if you wear the tip, the coating of the tip off, the metal underneath is not ideal for
Hey,
for
so I
soldering.
noticed that some of these pins are a little harder to solder than others. Why might
Mhm.
that be?
Is it always the same pin
Ooh, that's hard. I can't tell because I'm on the back.
on the
So,
back? Yeah. So
yeah.
my guess would be the V and G pins, which are the 5-volt and ground pins, are connected to large 5-volt and ground copper pores, which is like a plane of solid copper on the surface of the printed circuit board. And so we use what's called thermals. So it's not directly that copper pore isn't directly connected to the pad. Each corner of or each quadrant of the pad is connected,
Like
and
a
then there's
little
a
plus
gap.
sign coming out of the pad.
Exactly. Yep.
Yep.
Exactly. And so that keeps the copper pore from soaking up all of the heat from your soldering iron. But even with those, yeah, you'll definitely find that your 5-volt and ground pins can be harder to solder than the data in and data out pins.
So that might
Other
not be you or your iron. That might just be the circuit board.
Yes, exactly. And, especially if you're working on a circuit board that didn't use thermals on ground pads.
Which I have been known to not do sometimes.
Yeah.
not
which is also,
not on a solder it yourself thing, though.
Yeah, which is also a huge advantage of a good temperature controlled soldering iron, is that your soldering iron, your station, can sense that the tip, the temperature is dipping, the copper is soaking up all of the heat, and it will ramp up heat. I also solder very hot. Like I use, just about as high as my soldering station will go. I don't remember offhand, 650 or 700 degrees Fahrenheit probably, just so that I can get in and out of the joint faster, right? And instead of having to hold the soldering iron tip on the solder joint, waiting for it to get hot enough to melt the solder, I damaged more components using lower temperature on my soldering iron than I have at a higher temperature.
I agree. I always like to solder at a higher temperature. And that's also another difference between lead and lead-free solder, is that lead-free solder melts at a higher temperature. So if you're soldering with lead-free, I would solder 750F at a minimum for lead-free. And I kind of like it more around maybe 780, 800 degrees for lead-free, because it just solders so much faster and easier.
Yeah.
This would be a great time to point out that if you're soldering with 750 or 800 degrees Fahrenheit, you're turning metal into liquid. And you notice that Carrie is wearing safety glasses. So every time that you solder, please make sure, especially if you're using a kit by Cyber City Circuit, please use safety glasses. Please use safety glasses. We sell them on our website too. They're only $5. We're not making money on them. We're selling them as cheap as we can because we want to make sure that you have safety glasses.
Can you scroll the legal disclaimer banner, Carrie?
Yeah.
we have that prepared.
Please do not hurt yourself, and if you do, don't blame us.
Oh yeah, we were supposed to do one for the speed soldering too.
That's right.
A long and fast legal disclaimer during that, and we forgot.
Yes.
Yeah. So not only do you have the risk of accidentally, pulling off of the pad and flicking hot molten metal at your face, there's also a risk. I've never had it happen. I have heard of, air pockets superheating and causing the solder joint to explode. So even through no fault of your own, you can get hot molten metal in your eye.
I have had old solder, basically. So solder where some of the flux has maybe dissipated or something in the core. I've had old solder crackle on me like that and kind of sputter a little bit.
Yeah.
Yep. That is definitely a thing.
Safety glasses are cheap. Eyes are irreplaceable.
Yep.
For now.
Yep.
But when they are replaceable, they're going to cost more than $5.
Yeah.
They will.
And we tried like 7 different types of safety glasses to find the kind that we like. So they're not the cheap kind. They're very nice safety glasses. We just buy in very high quantity. So we get a volume discount. We pass that on to you because we want to make sure that you can see when you're done with one of our kits.
Yeah, and get a good pair that are comfortable and easy to see through, because then you're more likely to wear them, right? If you have cheap ones that hurt when you put them on, you'll find a reason to not wear them.
Yep.
especially the Fibonacci cat. I mean, imagine soldering all this together and not being able to see all the beautiful lights. It would just be
Right.
ironic.
Yeah.
So is that the
Right.
last couple of? Is that number
I think
127,
so.
128
I
there?
think I'm on the last two. Ooh, I just bridged two.
I was gonna see if I could engineer a bridging discussion into a bridging talk into the discussion, but it just did itself apparently.
But
Yeah.
so how are you going to fix that, Carrie?
So I just
Walk,
fixed it.
walk everybody through that.
I just fixed it. It was super easy. It was a small bridge. So I basically just cleaned off my iron and then just wiped through the center of it. And that was enough to just get that little bit of excess solder out, which I then wipe off my soldering iron again and then reflowed both of the pins on either side so that there were no last little like misshapen elements reaching towards the next one, and that was it. So it didn't even require solder wick or any other tools.
Rewinding slightly, what is a bridge and why is it a problem?
So a bridge was when two of my pins that were next to each other were actually connected with a blob of solder, and that's a problem because it means that those two pins are shorted together, and the two wrong pins shorted together could actually damage a component on your board, like the LED, or it would, at the very least, not work very well.
Yeah, and that's a great segue. I didn't put it in the instructions, but I would highly recommend after you're done soldering, and maybe even before you put the nano on, get your multimeter out and use either the resistance or the diode check or continuity test to make sure there is not a short between 5-volt and ground. That is the most important short to check for.
That is a very good idea. So I think I am actually done. I think I've gotten every single one of those little buggers.
I think so. So one good thing about this board is it's fairly hard. You would have to try pretty hard to short 5-volt and ground because they're on the opposite side of the LEDs. But you could have two LEDs that are adjacent and accidentally bridge between 5-volt and ground. So what would be more likely is you would either ground, input to 5-volt, which would just keep the LED on, or input to ground, which would keep it off, or output, which would affect the next LED. So
another thing I like to point out, Carrie's doing right now, she's snipping the leads. You notice that she's putting her hand over the lead. If you don't stop the leads from leaping into the air into your face, they will leap into the air into your face when you snip them. Again, please wear safety glasses.
Yeah, and especially these leads are very thick and hard and pointy, and you'll find them getting embedded in your fingertips. And if you don't have the calluses built up for that, you can use a metal thimble if you have one, or if your grandma has one. Or I have this nice silicone thimble thing that comes in handy for that as well, and it's kind of grippy.
When I teach these in classes,
would work pretty well too. I think just
what's that?
I think even just like the cheapo finger cots might work pretty well.
Mm-hmm.
When I teach in classes this cutting leads, what we'll do is we'll take a magnet tray, the kind of trays you can get at a store like Harbor Freight that you can keep nuts and bolts in, and we'll hold the board upside down, and then you snip it, and then they don't get on the floor. Instead, they just fall right into the tray, and the magnet holds them on the tray, because then they don't get into your feet. That's another thing. You get them on your carpet, they don't come out. Vacuum cleaners do not pull them out. They live there until they get into your feet.
Yeah, they're like Velcro, right?
Yep.
Right.
Which is another advantage of using.
Try to make an effort to not let them shoot around the room, to not get into your carpet, to not get into your eyes, your pet's eyes. Don't let your pet eat the stuff. Because if you have an animal around, they eat anything.
If you got lead solder as well, there's going to be some lead on there too.
Yep.
One more reason to not use lead solder. There's no safe level of lead in your body, right?
Yep.
Above zero, all levels of lead in your body are bad. So.
And especially for kids too.
Yeah.
Yep. All right. I think I'm clipped.
So when you were clipping those, do you put them flush with the PCB?
I do not. I don't clip. I avoid clipping things flush because I don't want to stress the pad. And I feel like when you clip, and that includes the solder joint, you know, you're going to be sort of mushing that solder. It's going to try to bend in certain ways, and it might take the pad with it a little bit. So I always try to clip right above the solder joint. And also, if you have to rework that for whatever reason, you know, having a little bit of leg sticking through is just like a little bit easier to rework.
Another thing that happens with people that they have problems with the soldering kit is they'll clip it flush to the board, and when they do, they scratch the board. And if you scratch the board, you scratch the trace, you break the trace, it's not going to work.
Yep.
And even if you don't break the trace, you're scraping off the solder mask, which, you know, is one more opportunity to introduce a bridge.
Right.
And besides, we work very hard to make our boards beautiful, so don't scratch them.
Yeah. Look at that beautiful black matte finish on that board.
Right, exactly. And so I'm actually clipping a few of the leads that are outside of the outline, just because, you know, I don't know how exact that outline is. I don't want the edge of the nano to be pushing against them. Who knows how close traces are to the edge of that nano, you know, probably not very, but you never know. And, you know, you wouldn't want one to be right on the edge and actually like short to a pin that was sticking up next to the edge of the board. So I'm just making sure a little bit of clearance all the way around it.
What's that shiny stuff around the pins? That's not solder. What is that?
Not. It is flux. It is residual flux that is inside of the solder, which we talked about makes for nice clean joints and helps the solder wet nicely and flow to the pad and to the legs. I'm also turning mine upside down and kind of tapping a little bit because I noticed there were like a little, sometimes the legs kind of got stuck to the board because flux is a little bit sticky. And so, you know, it can sometimes cause the leg to just like stick to the board, and then you could actually short something out that way. So you want to make sure that your board is free of clipped legs when you're done too.
Speaking of flux, did we talk about ventilation at all?
We did not. I'm not setting a very good example right now. I'm in an enclosed room, but it is a pretty large room with a relatively tall ceiling for being inside. So the reason that I don't have the fume extractor on is just a noise thing. So what I really need to do is like get one of the little clip-on mics and see if that picks up fan noise in the background. But I also have been soldering for a very long time, and I have a habit of holding my breath when I solder. So I'm not breathing in those flux fumes.
Yeah.
And it is just sort of like an older school trick that pretty much everybody does who's been soldering for a very, very long time. You just kind of get into the habit of it. So
yeah, so just to back up, the when soldering, even with leaded solder, the smoke that you see isn't the metal, it's the flux, and that is not good to breathe in. And if you're in a large, ventilated room, even just a good breeze to carry it away from you is like minimum, right?
Yeah, it is helpful to have some air movement within the room. Like even
another
just,
thing
the
that
system is probably sufficient. Yeah.
Another thing that's really important when talking about flux, as Carrie was saying, flux is sticky. Yeah. Additionally, flux is toxic, and if it's on your hands, it's on your fingers. And let's say you're going to go eat. When you're done, it gets on your food. If it gets on your food, it gets inside your body. And it makes a very nasty time in the bathroom. So, whenever you're done soldering, wash your hands. Always wash your hands. Yep. Just wash your hands. It's easy.
Yep. Always, especially if you're using leaded solder. But
especially.
So, do you?
I was just gonna say, is there a way we could remove that flux if we don't want to be looking at that stuff on the back?
Yes.
Or do you need to? Are you going to clean that, Carrie?
I I don't think I will, which will probably cause Jason to cry in his sleep.
Are you using no clean flux?
I believe it is. So this is interesting. I've been looking into the different fluxes available with lead-free solder, and so with leaded solder, there's typically three types of flux that's used: no clean, rosin, and water soluble. And rosin usually means rosin RMA, which is rosin mildly activated, and it has sort of a yellowy color and a piney smell to it. Whereas no clean is clear and has more of like a perfumey smell to it.
But how does it taste?
I don't put solder in my mouth because you should never put solder in your mouth.
You passed the test.
And so, but it seems like with lead-free solder, what I see a lot is soldered labeled as rosin, as no clean rosin. And I think that that's interesting, and I need to read a little bit more about that. I mean, no clean is a formulation of rosin. It's just not quite as effective as rosin RMA. In general, you do not have to clean no clean solder off because it is very inert. It is not very electrically conductive, and it is not corrosive. And in fact, I think some fluxes might actually kind of protect solder joints a little bit. They kind of form like a little bit of a hard shell to it. So that is kind of nice. However, it also, this particular stuff seems to be pretty good. Like I didn't have any trouble with it wetting out or reflowing. But when you're just learning, I really like the rosin RMA solder because it just gives you more working time and is a little more aggressive at cleaning your joints and easier to work with. But I haven't really been able to find that with the lead-free yet. So yeah, so I need to do a little bit more digging with that. But even the RMA, you don't have to clean off. But if you're in a really humid environment, I probably would. But it has many years until it starts to corrode your joints. But it does maintain like a tiny bit of conductivity. So if you're doing super, super low voltage stuff, that can actually get in the way.
Which kind does?
The rosin RMA solder, okay. the yellowy, piney stuff. Water soluble is super conductive and corrosive. And that's why you always have to wash off water soluble flux.
But you can use water as opposed to
isopropyl alcohol, which is required for to really clean off the rosin RMA and the no clean.
Gotcha.
Yep. Okay. And you really need the 90% or more isopropyl, the kind that's been impossible to find since COVID, which thankfully seems to be in stock again at drugstores. But yes, you need the 90% stuff. Otherwise, it won't get all of the residue off.
Question from the comments: what percentage of silver do you like in your lead-free solder?
That's a good question. I'm not yet a connoisseur of lead-free solder, so I've been using tin, silver 0.3, copper 0.7. So I assume it's tin 99.1. Oh wait, 0.7, 99% then. Yeah. I assume that the tin is 99%, the silver is 0.3, and the copper is 0.7. And it says 2% here, that's the flux content. So, and I have not had problems soldering with any solder that says that it has 2% flux content. So it may be that lead-free solder has like a little bit of a bigger flux core than leaded solder generally does. And that probably also reduces the cost of it too, because silver is kind of expensive and so is copper.
Yeah, so sorry, I missed it. Mine is SN 99.3. What is the SN?
Tin.
Oh, that is tin, right. And then CU copper is 0.7, and mine has 0 silver.
Oh, interesting.
And it is no clean water washable.
Okay, so no clean water washable.
That's what it says. It's by Chipquick.
Man, they really
it's
mix up all the fluxes, and I
Yeah,
really
it's-
don't know how to interpret that.
It's 0.38 millimeters, so it's very fine stuff.
Interesting. Well, there might have just been a lot more happening with flux technology lately than I'm aware of, because usually no clean and water soluble were two different things, but maybe they actually do have no clean that is water soluble now, which would be kind of cool.
Another thing, I'm going to use this as a way to hook.
Yeah, maybe David knows more about this.
So we are an electronics manufacturer. That's our primary source of income. And we use a very specific solder that we get from our parts broker in China. And we also sell that on our website. So when you buy the solder from our website, that is the exact same solder that we use for our job. So it has to be reliable, or else we couldn't use it. So if you want good stuff, try the stuff that we sell on the website.
And what is that stuff? Is it water soluble? Is it no clean? Is it somehow both?
It's no clean. It's no clean. It's tin copper, no silver.
No silver? Cool. I would like to try that out.
0.8 millimeter. 0.8 millimeter just seems like the best solder that we've ever tried. So that's all we use. And it comes off really clean in our ultrasonic cleaner because we wash most of the things that we manufacture also.
Nice. Yeah. And you're cleaning that with isopropyl?
No. So that is a great question. Never put isopropyl alcohol in a ultrasonic cleaner. Isopropyl alcohol is explosive.
Well, yeah. It's flammable.
But we use a detergent by a company called Vestron, which is, according to their MSDS sheet, environmentally friendly. And we use that, and you dilute it. So it's like $200 a half gallon, but it's enough to last like near a lifetime because you dilute it 10 parts to 1 part. So it's essentially like, what would that be? Like 5 gallons, 12 gallons, something like that. But it comes off really clean in the cleaner with water and this detergent.
Nice. So I'm noticing that the nano is in fact like a little bit longer than the outline on the PCB. So I actually had to cut off a couple more leads so that it would sit flat.
If you were reading the instructions, it would have informed you to trim all of the leads, I believe. Because who wants spiky pointy bits on the back of their
circuit board? I certainly could trim all the leads, and I might in fact do that later.
Yeah. Somebody else brought up the fact that there are 4 mounting holes, very tiny mounting holes in the corner that are only slightly larger than the header pin holes. And to make sure that you actually get it, it is possible to get it one set of pins too far in either direction.
Yes.
Which will not work very well.
Yes, I did notice that. So yes, careful that you line up the pins on the actual pins.
Yeah. If we do another revision of the board, I will increase the size of the outline.
Another thing I thought was interesting is it's only using 8 pins off of that whole board, right?
It's actually using much less. The corners are there. All of the corners are there just for structural integrity. It's only using 5-volt ground and 1 of the pins for data in to the LEDs, and then 2 pins for the push buttons. So it's actually only using 5 pins.
Nice. I'm cutting a few of these a little bit shorter because I kind of felt like there might be a little bit of something hitting. So I am going into the solder just a little bit with this.
Are there components on the back of the Nano, the bottom of the Nano?
There are components on the back of the Nano, and there are some capacitors that stick up a little bit.
Yeah, definitely don't want to damage those.
Yeah.
Yeah. Just wanted to mention a tip from Alfred, which he shared before. I really like. He has his soldering iron connected to a timer, so that he can't leave it on for a long time because it'll just turn itself off. But
Nice.
That
Yes,
is a
I'm
good
a fan
tip.
of soldering irons with automatic shutoffs for sure.
I don't have a timer, but I have mine in the same power strip that my light is on.
Exactly,
So when I
that's what
turn
I'm
on the
hoping.
strip, my light
Yeah.
is on. If my light is on, my soldering iron is on.
Same.
I do that here at the shop. I always have for the benches, the main lights over top of them are plugged into the strip. And I like if there's a chain, I try to take it off or just make it super short so that you can't reach it very easily. Because yeah, that way I know if the light is on, the bench is still on, and the strip is still active, and the soldering iron could potentially be on. So
Yeah.
we always turn off the strips at the end of the day.
Yeah. My fume extractor fan is on the same strip. So if I hear the fan or see the light, I know that my soldering iron might be on.
Nice. Well, should I test this without soldering it first?
So you might find that you need to kind of
Yeah, like,
hold the nano at tension.
mm-hmm. It's
Um,
pretty, that's
yeah.
relatively tight on those pins.
Give it a shot.
Let's see, I need to get a USB cable. A
Your
mini.
kit should have come with one.
Oh,
was
that's
in
right.
a little baggie.
Look at that. USB
Yeah.
cable. Excellent.
Because the micro USB is a little dated,
Everything.
it is good that they include one.
Yeah. I do like the minis, though. They're a lot
It's
easier
very-
to use than the micros.
It's very robust.
Yes. Yes. All right.
All right.
I know, right? Here's the...
Smoke test. Oh wait, did you continuity test?
I didn't continuity test. Let's continuity test.
Or are you
Let's
just
do
going
it.
to
All right,
YOLO?
so now I definitely do need to grab a multi.
So yeah, David, the push buttons are just between two separate data pins and ground with internal pull up, pulled high. So those are the only pins that are needed.
I know.
It was challenging finding a spot on the printed circuit board that had openings, and I couldn't have run the full header, which is why
Yeah.
it only has 2 in each corner and 2 in the middle for the push buttons.
So multimeter use, when you turned it on beep mode, you always want to check and make sure your multimeter is in fact beeping before you beep something out.
Mm-hmm. So you're going to test between 5 volt and ground.
5 volt and ground right now.
And it's not uncommon to get a real short beep when testing between 5 volt and ground. If there's a capacitor anywhere on the circuit board, that's the capacitor charging.
I'm not hearing any beeps.
That's good.
I'm happy. No beep between ground and data in. No beep between data in and 5 volts. No beep between 5 volts and ground.
Mm-hmm. And then you could test between data out as well if you wanted. But
I could test between, the data.
on the other side, there's a data out in case you want to connect this to even more LEDs.
How many can we chain together?
How high a frame rate do you want? It's 30 microseconds per LED. So.
Alrighty.
So 30 microseconds times 32 LEDs is 960 microseconds, right? So then if we do 1,000 divided by 0.96, we could theoretically get 1,041 frames per second
I have to turn my
if
light
this little nano was capable of it.
So
There we go. I see lights.
yeah,
It's a little
there we
glitchy,
go.
but yeah, that's just the tension. Probably.
Yeah, that's just the tension.
Yep.
But I have seen they are all lit. Yay!
That's a good sign.
Awesome. So I'm gonna solder this puppy on and do it for real. This is so exciting.
You're gonna flush it down as far as you can, or you're gonna elevate it a little bit? What's the strategy there?
No, I am having it sit on the headers all the way down so that I can put the diffusion kit on it.
Cool.
Yeah.
That's how I did mine, but I do trim my leads very short.
Very short.
But it looks like there's plenty of clearance underneath it.
Yeah. you for not making us solder all of those.
I couldn't find a place on the board where a whole strip of header pins would even fit. So I was lucky to find a spot where I could get the corners and the 2 additional pins for the buttons.
Nice.
Yeah. And yeah, you could chain these, and on any additional boards or strips, you wouldn't need another microcontroller. You could just use this Nano and modify the firmware, which is open source Arduino compatible code. You could just modify the number of LEDs on it, and it should just work.
Additionally, you could chain this with any other Fibonacci product that Jason Coon has made. So you could take this and the 256, for example, just tie them together and use one Nano to drive all of them. You may want to have an additional way of getting 5 volts to the second one, but it will work.
Yep.
Trying to get.
Yeah, you could connect ground between the 2, but not 5 volts, and power the 256 separately. Really, any LED that is compatible with the NeoPixel library or Best LED library. Yeah. It looks like it works.
It is. It totally is. All of them are on and changing colors. I'm gonna try to make it really dark in here. Hang on.
You should be able to use the power and brightness button to increase the brightness of the pan of the board as well. It's more than capable of blinding you even in ambient light.
Blinding. So
yeah,
I'm guessing this is the low of lows.
I started it out at the low.
Oh.
Towards the low end.
Oh, there we go. Look at
My
that.
question from the comments was the acrylic separate?
Yes, and Cyber City Circuits.
Yeah, the acrylic is separate. I wanted to try to include it in with the kits, but acrylic's expensive. But we did. But Jason, we bought 25 of the acrylic kits from Jason that he manufactured himself and with his own 2 hands, and
laser.
And laser.
And they are currently on the website for sale right now.
Cool.
And if you want any additional kits, or if someone's watching this in the future and would like to buy one of these kits, currently we are out of stock, but you are able to back order the kits, and when we get them back in stock, in probably a few weeks, we'll ship all of those out. We have to get caught up on some other work first.
And just a reminder, this is part of a monthly subscription service, right? Where you could get something.
That's right. So this kit, if you went to go buy the kit on our website right now, it's $30. It's $29.99. But it was part of our monthly soldering kit program that is $15 plus shipping, and so these kits cost us more than $15 to assemble to get them mailed out to you. But we are happy to do it, and it's just $15 plus shipping, and then each month we have a new kit. Next month we're going to try this really cool digital alarm clock kit that has a built-in MP3 player. The boards for that just shipped yesterday, and we're crossing our fingers to make sure they work perfectly so that we can ship them out. We try to ship our kits out on or soon after the 15th of each month. So if you sign up before the end of the 15th, you will get that month's kit. If you sign up after that, you won't get that month's kit. You'll get the following month's kit.
That makes sense.
So here's what the acrylic kit looks like. It's just 2 pieces of, you've got it there. 2 pieces of acrylic and some M3 standoffs and some M3 hardware.
Ooh, check this.
And I think, David, correct me if I'm wrong, I think they come with one of these shiny Evil Genius Lab stickers as well.
They do. So Jason packed each one with stickers. They all come with stickers. They also come with the screws, the black, I believe they're black oxide.
Yes.
Is that right, Jason?
And they're black standoffs too. It is all very
it's very sharp. Jason did a
nice.
really good job putting that together. I would have used brass standoffs.
I know, me too.
Right, Jason
I know.
did not cut corners.
They are nylon. you can go with the anodized aluminum, but those are a little more expensive. So.
Speaking of cutting corners, are we gonna break this out of the panel somehow?
Oh yeah.
Oh,
and be
well.
careful. JP warned me that the corners on those panels are a little sharp, so be careful when popping it out if you do.
Yeah, let me just get done screwing these 4 in. I'm just like hand tightening right now.
And that's the back, is that right?
This is well, it says to insert the hex screws into the matte side of the acrylic faceplate, and I assumed that the faceplate was the one that was.
Yeah, but you'll want to use the standoffs that have the threaded, so they're M5 plus 6 millimeter. They're the ones with the male threads on the end, not the female on both sides.
Ooh, got it.
Because then those go through the PCB. Yep.
Right.
There should be a diagram.
Male ones.
I think there's a diagram in the instructions on the site.
Yes, there even is. I'm not looking.
No,
it's
worries.
up on my phone, and I'm like still not paying attention to it. So,
yeah.
Yes.
My site is probably not formatted the best for mobile viewing on mobile. But
it actually looks good. Looks fine.
Good.
Yeah.
They're large pictures though. Yeah, I have a exploded CAD view.
Male, female.
Got some subscription excitement in the comments. People excited about the alarm clock. Is that the one with the capacitive logo button, David?
Oh, that's right.
So we were trying to do the capacitive touch snooze button, and we could not. So there's lots of different flavors of Arduino Nano clones, and it seems that some are less authentic than others. But that's part of how we're able to make our kits $15 and include Arduino Nanos that we test them all, but they don't always work the way that you think they should. So we couldn't get the capacitive touch to work on the ones that we carry in stock. So we decided against that. Instead, we used a bunch of buttons and we made a snooze bar. And it's still going to be very fun.
Carrie, are you snapping that off camera?
No, I'm reading the instructions. So I noticed a thing, and I'm not. Oh, aha! Never mind. I think my question was solved for me, maybe, because it looked like one of the standoffs was going to interfere with the Nano's power with the USB. But it looks like we only have 3 standoffs on the back. Yeah?
Yes, and you should have an M3 nut for the 4th.
Yes. Got it.
And I think one of the threads on one of those standoffs is probably shorter.
Oh, okay. Let's see.
Jason, I'm curious, how is it with the Nano versus the ESP?
Not bad. I mean, uploads are fast. For this few LEDs, the Nano is more than capable of driving it. You just don't get any of the web capable features that you get with the ESP8266 or the ESP32 that I usually use. So, like if you buy one of the fully assembled Fibonacci's from a Tindy store, it'll come pre-flashed with the firmware that you just plug it in. It exposes a access point. You connect to it, you get it on your Wi-Fi, and then there's a web page that you go to, and you can control power, brightness, pattern, palette, all of that. Which is why the buttons, it was important to get the buttons on this so that you can cycle through different patterns and brightnesses. But other than that, no, the Nano's great.
And is that sketch available somewhere to make your own patterns and things?
It is, definitely. It's all open source. There is a link to it in the instructions page on evilgeniuslabs.org. And the code is up on GitHub.
All right.
It all uses the...
So now I have a short standoff.
Mm-hmm. I think all of the Nanos in the kit come pre-flashed, so you definitely don't have to do it. But yeah, absolutely, if you're interested in digging in further. There's...
You don't have to add headers or anything like that to be able to do that.
Right, yeah.
So every kit that we make comes, if it has a microcontroller on it that would require a computer to program it, we make an effort to pre-program every single one of them. And as a matter of fact, I pre-programmed every single nano myself. And it takes some time, but we did it.
Yeah. But yeah, the code is all open source, and yeah, I definitely recommend. I tried to add comments where I could. It uses the Fast LED library, which is great, and there's an amazing community. It's on Reddit now, but a great community. If you get stuck or you have questions, the community is really great about jumping in and helping. So, good question. Definitely recommend digging into it.
Right.
That's a 328 on the Nano.
I think so. 328p.
They are a 328p-esque microcontroller.
Mm-hmm. So when you first plug in the Nano, the very first pattern was made by Mark Kriegsman, who was one of the creators of the Fast LED library and still active maintainer. And it's just this amazing animation called color waves with palettes. And it has looked just amazing on every LED thing that I've ever made, whether it was a strip or a 2D matrix or a Fibonacci display or a disc or a set of rings. It just always looks amazing. And it just particularly looks amazing in the Fibonacci layout with the right mapping. It's what results in the cool rotating spirals and
nice.
Yeah. Huge fan of it in the Fast LED library and of Mark Kriegsman in particular.
Okay, so now I have the screws all screwed in. I'm just doing it with my fingers because I don't have a hex key super handy right now. So
I think that's about the right amount.
So there we go. I still haven't broken it out yet. I just want to plug it in again and see how it looks.
Yeah. So you can see the rounded corners that I put in the back plate so that you can still easily get to the buttons.
Yep.
If you have fat fingers.
And a nice little round hole for mounting it, like a little keyhole guy for putting it on a screw or something. And let's see, turn this back on.
I was, the first few of the enclosures like this I was 3D printing the back plate, which can take 20 minutes, or as soon as I got my laser, I can cut that same part out of acrylic in about 30 seconds. So
nice.
Yeah.
All right. So I'm going to unpower it before breaking it out. Let's see, because I think that's the last thing, right?
I think so.
I generally like breaking out boards with pliers, and I have these nice pliers that are not serrated at all. They're flat on the inside and they're pretty wide. I don't quite recall where I got them, but I will dig up that information and put it in the description of this video later. So yeah, these are usually what I use to break stuff out. I think that they'll be long enough. And I try to get it like as near as I can to the little mouse bites. And then I just like lightly wiggle back and forth. I think I got that one. So again, hold close to the mouse bites. Wiggle back and forth.
Will you have to cut the edge to get it off?
I don't know. I was just like, is the acrylic?
Because the acrylic is a little, I think 2 millimeters wider than the printed circuit board.
That's okay. I can take the back plate off.
Or you could just cut one of the sides, maybe. Yeah, those pliers are nice. I only have the needle nose with the serrated, grippy.
Yeah, I've never seen non-serrated because that's the problem is they munch on your thing and ruin it. So that's brilliant. But comments say you can find the smooth pliers at craft.
At where?
Craft store.
Oh, craft stores. Nice. Yes.
Jason, there's a little question about power sources and things shutting off there for you.
I'm gonna get an L or a hex key super quick.
Stops if you use a power brick. You might. with it plugged in, you might test the voltage between the 5-volt and ground pads on the edge of the board, and make sure you're getting somewhere near 5 volts. I'm thinking maybe, and check the current rating of your power brick. A lot of power bricks are only rated for 1 amp or even 500 milliamps. And you could probably run this sketch off of that. At the very top of the sketch, there's a setting for milliamps, and we use Fast LED's power management to keep current draw underneath whatever amount you set based on the number of LEDs and brightness and everything. And it may just be you have a power brick that's not rated for enough current, and it's shutting off like a overcurrent protection.
Is there any chance it's in the other direction? Is trying to do something clever and think, you're not, it thinks it's trying to charge a phone or something, and it's like, this isn't enough current, and it's just
Yeah, it's possible. I know especially some rechargeable battery packs will actually turn themselves off if the device is drawing too little current.
Yeah.
And they're actually devices that you can plug in between your rechargeable power bank and your device to keep it from turning off. So
usually
I would say try.
Yeah, sometimes they have the smart one and then just the dumb one, and you can just use the dumb. You can use the dumb connection if the smart one is being too smart and shutting you off.
Yeah. So I just happen to have within arm's reach 4 different USB power bricks, and you can see this one I have helpfully labeled is only rated for 1 amp, and this one is only rated for 1 amp, but this one is rated for 2 amps, and this one is rated for 3 amps. So because it's usually in really fine, dark print on the bottom of it.
Black writing and black plastic.
Exactly. So use a flashlight to read it, and then get some masking tape or a label printer and print it out in large letters for you.
The fusion looks brilliant. It makes such a difference.
So pretty.
Yeah, and that is acrylic. It's black LED acrylic from Tap Plastics, which is just amazing stuff.
Nice.
Yeah, it's great. You can buy it from them. They can cut it into squares and squares with rounded corners for you. But if you want to laser cut, and you don't have a laser cutter, you can do that through Pololu.com. And they will actually order the Tap Plastics. They'll order the acrylic from Tap Plastics, have it shipped to them. They'll laser cut it using your design file, and then have it shipped to you.
2 thumbs up for Pololu there.
Yeah.
Wait, you're thinking
Pololu?
Did you say Pololu?
Pololu.
For doing it. I haven't used them. I've used Pinocchio. That's who I've used. 2 thumbs up for Pinocchio. I don't know. I think that they might have LED plastic too.
Oh, okay.
Yeah, they're up in the Bay Area, so they're super fast turnaround for me.
Yep. But so that's how I had to have the acrylic done for the 512 and for that monstrosity in the background, because my laser cutter is not large enough to do those. So I had Pololu order the acrylic from Tap and laser cut it and send it to me.
Interesting. I didn't realize that Pololu did laser cutting.
They do.
They're like the ones that sell like robot parts and stuff like that, right? That's who we're talking about.
Exactly. Yep. Yeah. But they have a form online. You can submit your DXF or SVG file and a description and choose your material, and they'll ship it to you.
Let's see. There we go. Pattern changing.
Really?
Yeah.
And so it automatically cycles through palettes, so you'll see the color change even if you leave it on the same pattern.
Nice.
There's a list of maybe 30 different color palettes, gradient palettes that will cycle through. The acrylic enclosure kit it's in Cyber City Circuits shop. I see a question there. I can't post the link. I don't think you'll see it if I did, but go to Cyber City shop.cybercitycircuits.com and then go to their do-it-yourself kits section. You'll see it in there.
So I believe the acrylic is actually going to be under maker partnerships-ish because it's not a soldering kit; it's an add-on. Right now
it's under do-it-yourself kits, but
okay, now I'll just leave it there.
I'll see if I can dig up a link, y'all. Nice. Cool. This is super fun.
Yeah, this was great. It was fun watching you assemble it.
Didn't make too many mistakes, do things too backwards. Cool. It's always so satisfying when like you solder something up and turn it on and it works. Oh.
The acrylic really diffuses the light really well. You see, it's like water drops
Mhm.
almost because it fades in and out. It's so cool.
Yeah.
Yeah, and I like the black diffusing acrylic because when it's off, it's black, not white, like most frosted acrylic that gets used for diffusion. You know, when the LED is off, then it's white, which is, you know, the opposite of like your TV or of what you would want for light, right?
Yep. Yep.
And, you know, when it's turned off, it just looks like opaque matte acrylic.
Mm-hmm.
So it's almost magical when you plug it in and it turns on and you can actually see light through it.
Yeah, it's really cool. So, oh, we don't have, yeah, no extra parts. That's the circuit board.
Yep.
Cool. Lights and no magic smoke. Yeah, exactly.
Yeah.
It's always a bit tense that first time. Like, whew.
Yeah, it's really exciting
Imagine
when
how I felt.
yeah. It's really exciting when your resistors become light sources. That's when you know that you've made
Or
a
air
terrible
fresheners.
mistake.
Oh yeah.
Yeah.
Oh yeah. Cool.
All right. Well, thanks.
Anybody
Thanks for
else?
having me.
Yeah, no problem. Did anybody else watching have any more questions or anything? Or did we answer all of the questions that you've already asked?
Right. Yeah. If anybody asks me a question, I've been a little in and out. I'm sorry. I'll be happy to answer any questions that you may have.
Yeah, or just hit us up on Twitter.
Yeah.
We're both up on Twitter. So
Yep.
Yep, so-
Genius Labs. Cyber City Circuits is at Make Augusta, and we're Alpenglow End. Yeah. Oh, you're welcome. Thank you so much for coming to our links. It was fun. Bye, Alfred. All right. Well, thank you, everybody. Thank you, Jason. Thank you, David. Thank you, iShotJR David, for doing a great job moderating. And yeah, we're going to be back next week with something. I don't quite know what yet. We'll see.
all right.
All right. Bye.
Bye.